Hello, thank you for joining me. Today we're going to look at area of these shapes here. So we've got rectangles and triangles, which we see in about year 7, maybe earlier, and trapezium and sectors, which come into play in year 8 and 9, in Queensland at least. So let's check this out. So first we've got find the area of this shape. And I've just included our formula sheet here that you should get on the exam. So all we have to determine is the name of the shape first, right? So what shape do you reckon this is? It is a rectangle. So I look on my formula sheet and I can see it's asking for area of rectangle, and I have a formula. Area is length times width. So if there's two variables written next to each other, it means they're multiplied. So let's just do it. Writing the formula first. Area is length times width. Then we'll substitute. Length is the longest side. So I'm going to put in length is 7. The width is 3. And it's as simple as that. And then we just check our units make sense. Area, think square meters. Think squared. So it's going to be square meters. So I think last time we looked at perimeter. If we were finding the perimeter of this shape, we'd walk around around the outside, add up all the sides, and our answer would be in meters because it's a distance. But let's keep going. Find the area of this shape. So what shape is this? It is a triangle. Area, so I can see my little formula down here this time. Area of a triangle. Half base times height. Half times the base of this triangle is 11. The perpendicular height, the height at right angles, is 5. And so I guess we'll be doing half of 55, 27.5. And always check our units make sense. Area, think square meters or square kilometers. We input kilometers, so I must get that out. So you always write a formula, substitute, calculate. Minimum 3 lines of working for measurement problems. And look at this shape. What shape do you reckon this is? So a lot of people get these guys mixed up. Trapezium, parallelogram, rhombus. They don't really struggle with square, triangle, rectangle. So this one is a trapezium. Trapezium. And I'll draw in what a parallelogram is. A parallelogram has 2 pairs of parallel sides. It's sort of like a squashed rectangle. So that's what a parallelogram is, a squashed rectangle, and a rhombus is a squashed square. And they've got 2 different formulas, but we're looking at this area of a trapezium. This formula does confuse some students, but it's okay. Formula. Write it out. I think sometimes it helps to put multiplication symbols in between when they're written next to each other. Okay, now what are A and B? What are A and B? They are the pair of parallel sides. Actually, I might label that. So you could label either one A or B, but it has to be these pair of parallel sides. So let's do it. We add them up. 4 plus 6. And the height is like that perpendicular height of the triangle in the last question. See how they've both got that perpendicular height? That's the distance between these 2 lines will be h. So substitute it in. Simplify it a little bit. So by simplify, we're thinking about bid mass. So it's always good to simplify it a little bit before you put it in your calculator, just in case you input a number wrong. 4 plus 6 is 10. So simplifying within those brackets. And then there's no indices, no division. We've got some multiplication. So we just have to do that. Half times 10 times 3. 15. And what are the units? Area, think squared. We input meters, so we should get out meters squared. So the area of this parallelogram is 15 meters squared. Remember that A and B are the pair of parallel sides. H is the distance between the parallel sides. Now we've got these ones. Okay, I'm going to cover up these for now. Do you remember what the area, or the rule for the area of a circle is? Area of a circle. Well, let's actually write them down here. Area of a circle versus circumference of a circle. So circumference means perimeter. But let's try and remember what the formulas are for these. So they all have a pi, an r, and a 2 in them, both these formulas. It's just where those go. So the area of a circle is pi r squared. The circumference, or the perimeter of a circle, is 2 pi r. See, they've got a 2, a pi, and an r. A 2, a pi, and an r. And then I remember area of a circle, think square meters. So area is the one with the squared. And that's all we're interested in at the moment. So I might just cover up, whoops. Might cover up this formula too. And let's use it. So we've determined that this is a circle. Area equals pi r squared. It must be the radius. And luckily we are given the radius in this one. So we can substitute right in. Pi times 2 squared. BIDMAS says indices first, so you can simplify it a little bit before you put in your calculator. And I always like to estimate my answer. So pi is 3.14, which is about 3. So I should expect my answer to be the answer to 4 times 3, around that amount. So I should expect around 12. And I'll just put it in my calculator, and it is indeed 12.57 if we're going to 2 decimal places. Then we need to make sure we give meaning to our answer. We input kilometers and it's finding area, so we should get kilometers squared. Now let's check out this one. So maybe I'll move that over a little bit. Just make that, shrink it up to there. Oh no, it's all falling apart. Okay, let's chuck it up here. 4 pi, and I think it was, 12.57 to leave space for this one. Now here, do you notice that this is a fraction of a circle? If we draw that, it's a fraction of a circle. And so what fraction of a circle do you reckon this is? It's a quarter of a circle. So what do you reckon the area of a quarter of a circle is? It's going to be a quarter times pi r squared. Just looking at it logically, it's a quarter of a full circle. So let's substitute it in. And calculate. 7.07, correct to 2 decimal places. Give meaning to our units. Give meaning to our answer. We input meters, so we should churn out square meters. Okay, so these fractions of circles are called sectors, and the formula for them is in your formula sheet. But you can think about it logically. If it's half a circle, then it will be half pi r squared, which brings us to this question. So this one here, think about what fraction it is of a full circle. And we know the rule for the area of a full circle. So it is half pi r squared. Half times pi times that. 0.5 times pi times 10 squared. Correct to 2 decimal places. Give meaning to our answer by inputting the units of squared. Now, sometimes, let's check out this slide. There might be sectors that you don't know what fraction of a circle they are, but there's a little angle given in them. And that's where we're going to use this formula here. So just comparing them, area of a circle is that. Can you notice that in an area of a sector, there is also the rule for area of a circle? So I just remember it as a sector is fraction of a circle. Fraction of a circle. Now looking at this fraction, we've got this little symbol called theta, and it represents the angle inside the sector, which we'll see. So these are theta in these sectors. And then you divide it by 360 because there's 360 degrees total in a circle. There's 360 degrees. And we're taking a fraction of the circle. So that's all you need to remember. So what I will do with these ones, you've got the formula on your formula sheet. So let's have it down here. We're looking for area of a sector. Area equals theta on 360 times pi r squared equals, I'm not sure why that keeps coming up and down, theta over 360 times pi times 7 squared. And actually, we know what theta is. Theta is this angle inside the sector, 45. And then into your calculator, I would put brackets around that. Or you can simplify the fraction beforehand, but it's all good if not. 45 on 360 times pi times 7 squared gives us 19.24. Area, think squared, so centimeters squared. Again, a sector is a fraction of a full circle. Let's write it for here. Formula, substitute. So theta is 147 over 360 times pi times 7 squared. 147 over 360 in brackets, keep it in brackets in your calculator, times pi times 7 squared. 62.86 if we're doing to 2 decimal places, and actually it is meters. So we should get out meters squared if it's area. I just wanted to check out this one. Now this one here, in order to use this formula, this is the inside angle. So this is actually theta. So looking at this one, it seems a little bit tricky, but it's all right. What does that symbol mean? We can find theta. It's not actually given. This symbol is a right angle, which is 90 degrees. So if I can just put a little arrow to there, 90 degrees. What if I need to find that leftover angle, right? It's what's left of the full circle, 360 take 90. And you can draw all over your diagram, whatever you need to do to find what you need to plug into the equation. So that's 270 degrees. And then we have our formula. We've got theta and we've got the radius halfway across the circle. So let's do it. Let's write our formula. Theta is 270 over 360 times pi times 6 squared. Keep that in brackets in your calculator. And actually notice I can simplify it a little bit for myself by cancelling a 0 on both top and bottom. Just a little bit quicker to put in your calculator. Times pi times 6 squared to 2 decimal places. That's 84.82. Give meaning to our answer, square meters. Theta needs to be that inside angle of the sector, so you may have to calculate it. I might try and trick you with a question like that. And I believe that this is the last question before we look at surface area. So in this one, this could definitely come up on the exam. We've got find the area, and it looks like we've got a couple of shapes in one. Okay, when there's a couple of shapes in one, I like to make a plan in the beginning that I come back to. And what I mean by that is, actually, don't want to do it that high up. That arrow keeps coming. Why is that? Okay, let's actually work down here. Okay, we've got two shapes. Let's say total area. Total area equals, well, what have we got? We've got this shape and we've got this shape. And we notice this is half of a circle equals area semicircle, which just means half circle, plus area, think about what this shape is, area of rectangle. So this is our plan that we think of when we see this shape. Now let's calculate them both separately. I'm going to calculate this bit. Area semicircle equals, well, it's a fraction of a circle. We know the area of a full circle is pi r squared. So this one's going to be half of a circle, half pi r squared. So half times pi times the radius squared. Now, we haven't actually been given this bit, so you've got to look at the diagram and try and deduce some things from there. Now, let's get a different color. If we see this, that's the same distance all the way across. So I can also say that this is 14 meters. Now, is this the diameter or the radius of the circle? Remember, diameter is the full way across. The radius r is halfway across. So you might just want to put like a little calculation on your diagram. Radius is 14 divided by 2, 7 meters. So let's input it. I'm actually I'll put a circle around that just so that we know to input 7 and not 14. So let's do that. Need to input the radius to the area of circle formula, not the diameter. All right, 0.5 times pi times 7 squared. Last question, hang in there, 76.97. And the units are going to be square meters. And then some people might just move straight on to the next question. We need to stick to our plan up the top. We've found the area of a semicircle. Now let's find area of rectangle. And we know a rule for that. We've also got the area of a sector up here, but just because it was a half circle, I thought let's simplify the formula a bit, not involve angles. So area of rectangle is length times width. Length is 17 times width is 14. 17 times 14, oops, 17 times 14, not 7, 238, and it is going to be meters squared as all. Do not move to the next question yet. We have to stick to the plan. So we have now found the area of the rectangle, and we can use our total area formula to work out the total combined area of this shape. So total area equals area of semicircle plus the area of the rectangle. And see how it comes out. 76.97 plus 238 will give us 314.97. And the units are meters squared. So that's that. And you might just want to write total area so your teacher can find where your answer is. And in the next video, we're going to look at total surface area. Now that we know most of our area formulas. Okay?